Welcome to episode 1 of Math Award and Math Tuto. I am Mr. H. Rico Herrero at your service. We are in the first week of the third quarter in Mathematics 9. This time, we will be engaging ourselves in another branch of mathematics that is as important as other branches, and that is geometry. As defined, geometry comes from the Greek words geo, which means earth, and metria, which means measurement. Thus, geometry deals with the measurement of the earth. Particularly, it studies the measurement, properties, and relationships of points, lines, angles, surfaces, and solids. For this week, you are expected to characterize parallelogram, which is a quadrilateral, using its properties and conditions. Specifically, you are about to learn how to find the measures of angles, sides, and other quantities involving parallelograms.
I can be a square or a rectangle, or I can lean over at an angle. I am a parallelogram. I am a parallelogram. Opposite sides are parallel, and that is how you can tell I am a parallelogram. I am a parallelogram. Adjacent angles add up to be 180 degrees. I am a parallelogram. I am a parallelogram.
Look at these pictures. What have you observed in these pictures? Which among these pictures represent polygon? And what kind of polygon did you see in the picture? If you answered quadrilaterals, you are right. A quadrilateral is a closed figure and a polygon with 4 sides. Parallelogram, trapezoid, and kite are the main types of quadrilateral. A parallelogram is a quadrilateral with 2 pairs of opposite sides parallel, meaning whatever extension we make to the opposite sides of a parallelogram, they will not meet or intersect. Parallelogram has special types: rectangle, rhombus, and square. These are all parallelograms because they have 2 pairs of opposite sides parallel. But they have their unique characteristics. Rectangle is a parallelogram with all angles are right. Rhombus is a parallelogram with all sides congruent. And square is a parallelogram with all sides congruent and with all angles are right. But then, like what I have said, this week we will be focusing on the properties and conditions that guarantee a parallelogram. Are you ready? That's great. But the question is, what makes a quadrilateral a parallelogram? Condition number 1. The opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are not just parallel, but they are also congruent, meaning opposite sides of a parallelogram have the same measurement.
Consider quadrilateral PQRS. In this quadrilateral, sides containing line segment PQ and line segment SR are parallel. PS is parallel to QR. Moreover, PQ is congruent to SR, and PS is also congruent to QR. Therefore, with these conditions, quadrilateral PQRS is a parallelogram.
Again, the opposite sides of a parallelogram are congruent. Condition number 2. The opposite angles of a parallelogram are congruent. Opposite angles of a parallelogram have also the same measure.
Look at this figure. In quadrilateral LOVE, angle L and angle V are opposite angles and they are congruent. Angle O is also congruent to angle E, which are also opposite angles. Thus, we can say that quadrilateral LOVE is a parallelogram.
Again, the opposite angles of a parallelogram are congruent. Condition number 3. The consecutive angles of a parallelogram are supplementary. When we say two angles are supplementary, the sum of their measures is equal to 180 degrees. For example, angles with measure 100 degrees and 80 degrees are supplementary because when we add these two, the sum is 180 degrees.
Consider quadrilateral CARE. In this quadrilateral, if the measure of angle C plus the measure of angle A is equal to 180 degrees, and if the measure of angle A plus the measure of angle R is 180 degrees, if the measure of angle R plus the measure of angle E is equal to 180 degrees, and if the measure of angle E plus the measure of angle C is 180 degrees, then the quadrilateral CARE is a parallelogram.
Again, the consecutive angles of a parallelogram are supplementary. Condition number 4. The diagonals of a parallelogram bisect each other. Meaning, the diagonals of a parallelogram are not just intersecting, but they are also dividing each other into two equal parts.
For example, if in quadrilateral HOME, diagonals HM and OE intersect at point T, and if HT is congruent to MT and ET is congruent to OT at the same time, then quadrilateral HOME is a parallelogram.
Again, the diagonals of a parallelogram bisect each other. Condition number 5. Either diagonal of a parallelogram forms two congruent triangles. Meaning, if we draw any of the two diagonals of a parallelogram, then we will have two congruent triangles formed.
In quadrilateral HOPE, if we draw diagonal OE and triangle HEO becomes congruent to triangle POE, then quadrilateral HOPE is a parallelogram.
Those conditions make a quadrilateral a parallelogram. Again, opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are also congruent. Consecutive angles of a parallelogram are supplementary. The diagonals of a parallelogram bisect each other. and either diagonal of a parallelogram forms two congruent triangles. Let us try to apply these conditions to this parallelogram NAPH.
Fill in the blanks by supplying the correct answer.
You did it great! This time, let us apply the conditions in finding the unknown parts of a parallelogram. Are you ready?
Find the values of x, y, and z on the following parallelograms.
Way to go! This time, we will solve a problem involving a parallelogram. Let's get it on!
Solve the problem completely and accurately. You may illustrate the given to serve as your guide. Given, quadrilateral WISH is a parallelogram. If the measure of angle W is equal to x plus 15 and the measure of angle S equals 2x plus 5, what is the measure of angle W? Since WISH is a parallelogram and angle W and angle S are opposite angles and congruent, then by substitution, simplifying the resulting equation, thus x equals 10. But since we are looking for the measure of angle W, which is equivalent to x plus 15, hence, the measure of angle W is 25 degrees. Looking at the same illustration, if WI is equal to 3y plus 3 and HS is equal to y plus 13, how long is HS? WI and HS are opposite sides of parallelogram WISH. Therefore, they are also congruent or equal in measure. Hence, we will have, by substitution, simplifying the resulting equation, y equals 5. Since we are looking for the length of HS, which is equivalent to y plus 13, therefore, HS is 18 units long.
Before we end this, let us always remember the conditions that guarantee a quadrilateral is a parallelogram. First, opposite sides of a parallelogram are congruent. Second, opposite angles of a parallelogram are also congruent. Third, consecutive angles of a parallelogram are supplementary. Fourth, the diagonals of a parallelogram bisect each other. And lastly, either diagonal of a parallelogram forms two congruent triangles. That concludes our session for today. I hope you learned something. Once again, I am Mr. H, and this is Math Nood and Math Tuto, saying mathematics is the basic of life. Love, learn, and embrace it for easy living. Bye!